Hello, welcome to Hawk Math. Today we're going to be trying to solve this integral. Now at first glance, it doesn't really look too easy. There isn't really any obvious u substitution that will get rid of the numerator, and integration by parts doesn't seem to work. Now I do notice this 3, 4, 5, and that might be of use later because of a right triangle, but for now I don't really know how to use that. So what do we know? Well, we know if we had some integral of the form 3 sine x plus 4 cosine x over itself, then we know this would be really easy to solve because this just cancels out and it's the integral of a constant. Now, we also know that if the numerator is a derivative of the denominator, then it's just the natural log of the denominator as an integral. So what's the derivative of this? It's 3 cosine x minus 4 sine x over itself. Now, we can also compute this integral really easily. It's just the natural log of 3 sine x plus 4 cosine x. So what if we could write these two integrals, if we added these together with some constant multiple of this and some constant multiple of this, such that the numerators had their cosine terms cancel out and have the coefficient of sine be equal to 5. Then we just end up with this integral. So let's see if we can get that to work. So let's try to make this equal to some c1 times that integral plus some c2, another constant, times that integral. Well, how can we do this? Well, we can distribute this to both terms, and we can distribute this to both terms, and that will give us 3c1 sine x plus 4c1 cosine x plus 3c2 cosine x minus 4c2 sine x, and we know that this must equal this 5 sine x on the numerator. And in order to combine our terms, just to make it easier, I'm going to write a plus 0 cosine x. Now we can see that we get two equations from this. If you look at the coefficient of the sine of x's, we get 3c1 and minus 4c2 equals 5. Now if we look at the cosines, we see 4c1 plus 3c2 equals 0. Now to solve this, I'm going to use elimination, so multiply this by 4 will give us 12c1 minus 16c2 equals 20. And multiplying this by 3, we get 12c1 plus 9c2 equals 0. And now subtracting these two equations, we see that we will get this minus this gives us 25c2 equals negative 20. So c2 equals negative 4/5. Okay, now we can plug that back into this equation to get 4c1 minus 12/5 equals 0, or that c1 equals 3/5. Okay, now we can plug that back into here. So we now have 3/5 times the integral of this will just cancel out and give us 1. And now over here we have minus 4/5, the integral of 3 cosine x minus 4 sine x over 3 sine x plus 4 cosine x dx. Now we see that this is just going to become 3/5 x, and because of the property we discussed earlier, the numerator is the derivative of the denominator, this just becomes minus 4/5 natural log of the absolute value of 3 sine x plus 4 cosine x, and don't forget the plus c. Now to recap, if we had some other numerator such as 8 sine x minus 6 cosine x, we could do the same operations, we just get different constants. So using this strategy, we can integrate anything of this form to end up with this as our final answer. Thank you for watching. I hope you enjoyed. Please like the video and subscribe if you want to see more.